Hey everyone, my name is Charlie Como, and this is my video lab report for our very first lab. And so, quick overview, we are using Newton's second law, the momentum principle, to analyze the motion of an object moving at constant velocity. And our video is taken through iPhone, our data collection is through Tracker, our computational modeling is done through GlowScript using the Python programming language. Our data analysis is done in Excel, and all these findings are done by me. So all of this is done with the goal to predict the future of this object's motion using the current state of it and its previous states of its data as well. And so I'd like to begin by talking about Newton's second law. I have on the screen all the different forms of it in terms of change of momentum, change in velocity, and acceleration. However, as I mentioned before, our object's moving at constant velocity, so we'll have no acceleration or any of that sort. So we'll also have no net force on it as well in our computational model. And so we'll need a different subset of equations to analyze everything in our lab. And this is how I derive the new subset of equations, starting from change in momentum, range for final momentum, divide both sides by mass to reach our velocity update formula, multiply both sides by time to reach our position update formula. And so this is our glorious object, just a tennis ball rolling across the top of my desk. And here's a video of it in the flesh from right to left. Great. And this is what my data looked like when I was extracting it from Tracker. You can see all the different data points held in the table below. And you can see the position versus time graph right on top of it. And I like to mention that at first look, it looks like our object is moving at constant velocity with a constant, consistent slope in the downward trend. And we can calculate our average velocity by taking the data points in our first and second frame using the formula on the screen. And after plugging and chugging it, I have a velocity of 0.565 meters per second in the negative x direction. And so I'll use that data and all of this other data on the screen to help set up my computational model in GlowScript. And this is what it looks like all coded up using the initial assumptions in the previous slide and the equations that we derived previously as well. And after that, I took the data that GlowScript produced, and in Excel was able to plot side by side the expected data shown in orange and the observed data shown in blue. And you can see as time goes on, the difference slowly starts increasing, which tells me that my model isn't necessarily the best. You can see in the graph below the distance between the predicted and observed as it grows with time to a maximum of about almost 5 centimeters. And so that makes me suspect that there could be some other underlying force, such as friction, that is making the total force on my tennis ball non-zero. And I was thinking that because the tennis ball is quite hairy, there's a chance that the increases the coefficient of friction against the ball with my desk, and that could be why my ball is slowing down, going slower than my model predicted it. And so, in reflection, I probably could have chosen a better object for more consistent data, such as a soccer ball, roll of tape, paper towel, toilet paper, anything with a lower coefficient of friction. Or I also could have rolled my ball faster. I rolled it slowly so that I could get more frames for my data. However, I'm not sure if rolling it slower would reduce the impact of force on my velocity. Maybe that could be a Lab 2 thing. And lastly, this was my first time doing an entire lab from home, and I'm pretty proud of that. So thank you for watching, and that is that.